Hello, everyone. This is Ahmed Mahmoud from DataMindAI. This session is part of Lakeflow Masterclass, and this is a continuation of the previous session on the Lakeflow as a demo, and we are using, as part of the demo, Databricks provided demo, which I'm going to show you how to download it if you want to do it yourself as well. So let us start. Now, the way I organize my demos, like I have created a folder, yeah, as you can see here, DataMindAI, and in that folder, I have created like a demo, and on that demo, there is something called CDC bike, as it were here. So in here, that is the CDC bike, which is a notebook. I have created a notebook, but you can do it in a different way if you want to. You can go to new, and then you can add, say, new here, and then notebook, and copy and paste this code here. So what this code is doing is it is pip installing the Databricks provided demo, DB demos, and then there's a list of it. So we are importing from that demo, this from that one, the demo itself, and there's a list of that demo. And today we are going to do this declarative pipeline CDC. Yeah, so that's what we are going to see today. And I have added this to overwrite because if you want to redo it again and again, you need to override it, because what it does is like it saves or loads the pipeline and the data, the volume and so on in the main side, the main catalog. So if you go to the catalog, you will see this declarative pipeline CDC. So that's what it is. Now we are going to look at we are going to spend the time using the pipeline, the CDC one. But before we do that, though, just as an introduction, if you click this page, it shows you what is required. Yeah. So what is the purpose of this pipeline? What it's doing, and the guidance, as it were, or the business case for it, and yeah. So implement the CDC with the Spark declarative pipeline. Now, importance of change data capture. This is like if you have the point here is if you have a constantly changing system, the transaction side or the operational side, if it is constant changing, for example, the retail industry, like buying, selling, and so on, and constantly, I mean, updating the system there, updating, inserting, deleting a record, or it could be also like a IoT. It's a stream of data coming in, yeah, from from a system, and or it could be like your database has been changing. The database like captures the change, and it puts it for you in a folder, and you need to capture it. You need to take it and then put it in Databricks. So the change data capture is an important side. So you would have you would use like Kafka event, anything which requires event. It could be a website where people can click there, and then your that click will go to your database, the transactional database, and then you want to capture those ones. Of course, those transaction data, which is like on the operational data. So um, so that is the importance of this change data capture. We need to capture the change and put it in Databricks. Yeah. Now the capture inside. Yeah. So there'll be a pipeline. There will be different kind of like capturing. You do like CDC capture. Like for example, if it is a SQL server, you need to enable it within the database. If it is you can also use like third-party tools, different kind of tools which help you do the same thing, capture the change. Yeah, the Bayesium is one of them. The Bayesium is one of them, and then you have Talent, you have Click Replica, Fivetran, Talent, Oracle, and so on and so forth. There's a lot of um, like third-party tools which can take from the database and put it somewhere which you can pick from. The DWS, data migration service in AWS is also one of them, which I have done like some demo on that, especially for Oracle. So if the Oracle is, for example, is sitting in AWS RDS, and therefore, if you want to do like the CDC side, it is slightly difficult to go to Oracle and do the job and link it with Databricks. It can be done, but the tedious, and therefore the best one would be like the data migration service in AWS, which is it works hand in hand and quickly as well with Oracle, and therefore if you use that one and you can put these files, you can take them like a JSON or CSV file and put them in AWS S3 packets. So, and then the Databricks Lakeflow will pick them from there. Or alternatively, if this SQL, for example, you'd go into SQL and then you enable the CDC, yeah, in there, and then therefore the SQL server automatically will just will put the changes in a table, and then the Lakeflow will pick those changes from that table. So the change will be like on that table, the change table, the CDC table. There will be like an operation, which is like, for example, whether it is a delete or insert or an update, and also the operation date, when it happened, the date, and there is a lot of metadata with the data in this capture. So that is again in Microsoft SQL. So now, once you bring those ones, and then you need to materialize them in your those events, as you call them. So those events which is coming from the source data, you need to put them into Databricks. So there is a very elaborate mechanism here, design pattern. So what will happen is, for example, this is it will drop it in a folder or in a table, and then your autoloader will check the change which is happening in the folder, for example, in the file. Yeah, whatever, if a file appears, yeah, dropped into that folder, and then the autoloader will kick in and then move the data, and then you need to have like a clean CDC data and so on and so forth. So this is the process which follows it. We will see it like slowly, because I think it is a bit demanding. It is not straightforward, and therefore we are going to take it a bit slowly. Yeah. Now, and here also there are a couple of information which help you to understand what is going on in each side, in each movement of the data. So that's we are going to implement CDC, and then we are going to implement slowly changing dimension as well, type 2. So as you can see here, the autoloader is working here, and then there's a clean up expectation, the data quality side, and then once you do that one, you would do like a materializing silver table by applying the changes, and then you will do like the slowly changing dimension. Yeah. So this is the flow which we are going to follow in this demo. Now, we can do it in a different way, but let me again go back to here, because we want to do it like the way Databricks is doing it. So if you click this, the pipeline itself, last time we were talking about the pipeline editor. So we are working again. This is part of that exercise, how to use the pipeline editor. It's a new one, a new edition for data engineers to work, and a very helpful one, very useful. It is an IDE for all the work you do here, and we spend a bit of time explaining what these IDEs look like. So if you go to this edit pipeline, it will take you to the pipeline editor. You can also go to that place. For example, if you go to new, and if you to new here, and then the pipeline editor, yeah, the ETL pipeline. So if you try to click here, it will also give you that option, this pipeline editor. So now this is what we are going to spend time here. Let me close this one. Yeah. Spare me. This is okay. Close this one as well, and close this one. Close this one. It was bringing. Yeah. So this is. I'm going to go through this one with you as well. If you, but probably I will go with the Databricks provided one. I'll try to explain what the code is doing. Yeah, and also I have a couple of them here, like dummy data, and to see the change which is happening, especially to understand the slowly changing dimension. So let us see the document here, the SQL script. Yeah, what is doing here now. If you are running it, so of course we saw it here as well. If you want to run it and see the graph, you have this icon here on the right hand side on the editor. You can toggle between opening it and closing it, but to have a space, I'm just going to close it. Yeah. Now we are going to focus now on the code here. Yeah, on the code here. So now this is, as we explained before, this is asset navigations area. This is where you organize your data, and you write your code here. Yeah, as like the source code. As you can see, there's an icon here. This is the source code. The others are helping. These folders are, you put those folders just to put different kind of helping code from different places. If you want to do exploration of the data, you will have exploration here, and you have codes here. Could be 3 or 4 files if you need. But we are going to focus on this one now, on one part. It could be also bronze, silver, and so on. But we are creating it one file to see just the flow. Yeah, this is a key part, is the flow here. Now, the first part is like you need to create like a streaming table. It's very important to get here. We are doing the SQL, of course. The Python is similar, but we will come back to it. But this is a SQL part to that one. Now, the first part is like, for example, you are creating, if you are using streaming, you need to have like a table which supports the streaming. Streaming is not like inserting a normal insert. What happens is like when in the normal insert, for example, you insert something in the table and that's it, it's finished. Yeah. And then you will do another insert. Yeah. So, but this one is not like that. The data is coming like every second. There is some data is coming, and you need to do the work yourself. So some is insert, some is update, some is delete. Yeah. Some is also nulls in the middle. Yeah. And sometimes also the event like. For example, it just there might be a delay, some an event which happened at 10 o'clock. Yeah, and if you are live, for example, in the evening, it might come the 10 o'clock evening, that one, instead of coming in its time. So it could have a different kind of thing, but there will be a stream of data coming in, and your table should be able to support that one. That's why you create the streaming table is called, as you can see here. Give it a name, and then this is the metadata, the comment. And what are you going to do there? So again, as we saw last time, you have these two, stream and read files, these two together, yeah? So the read file one is going to monitor this folder, this site, this location. If there is any change, yeah, and then the streaming will kick off, and there will be like the data start moving from this one to the table we created on the top. Yeah, so that was going to happen here. So the stream is like a stream of data. This is like an engine which will help you to move the data, and this is the autoloader, we call them. This one is the autoloader, the one which checks whether there is something new arrived, yeah, and if there is new arrived, then we need to move them, kind of thing, yeah. So this is this side, and then infer column. Also, this autoloader has two additional functionality. It can infer schema. Is also it supports automatic schema evolution. So if there is any change, there's new column coming in. If they added new column on your source data, it will add it as well on the destination. Yeah. So this is the schema evolution. So it has this functionality. It infers the schema, what is the schema there, and the schema evolution as well. So this is the autoloader. This is done. We have done this one before. This is like similar to the previous one. The only difference is we were doing it for CSV, and this format is a JSON file. And we are adding this infer column type as well. Yeah. So this is number one. Now, number two is you need, you move the data now. Yeah. It is in the volume or in your system here now. You do some kind of data quality and cleanup. Yeah. Now there is this expectation. Expect is called that. As you can see here, expect. Yeah. What do you expect? Yeah. So you want to this and these two, constraint and expect. Yeah. You want to you have valid ID. What do you expect? The expect is ID is not null. Yeah. And what happens if you receive null, for example? That's what you know. So on violation, drop the row. This is a bit dramatic one. Yeah. So you drop the row in violation. Yeah. So that's what you are doing as a data quality. You can quarantine this as well, but let us say drop the row. Yeah. This is one. This is again valid operation. So the constraint valid operation. What do you expect on the operation column? Yeah. The operation column of the change. There is a column called operation, and it should only have this: append, delete, update. Yeah. If there is an upsert or truncate or something like that, it is not supported here. So you are saying you are just restricting it to these three only. Yeah. So on violation, drop the row as well. So if any nulls come in here, or if there is absurd or any other kind of in the operation side, it will be dropped as well. And this is it should be valid JSON scheme as well. It's constraint. And what do you expect here? There is rescue data is called is null. Yeah. If there is rescue data is null, which means it is not this is valid JSON schema. If it is not, then it violates, and then you can drop the file as well. So this is a rules. You can put as many as you like rules, but this is like you can say the owner should be there, or I don't know. the metadata should also be there, and so on. Whatever you feel that they should be there, you put it on the expect here, and the constraint. What is the constraint? What is expected, and then what happens if that is done. So what you are doing is you are creating a clean. This is to clean up this data here. So we call it again clean this table, and it is a streaming table as well. Yeah, it is a streaming table as well. So the one we are creating is the clean is creating. So it's going to check this one again. This is the one which is coming. You see, stream customer CDC. Yeah, this is a customer CDC from there. So it is checking all this stuff. Yeah? And then it is selecting it, and then it is going to put it here. Yeah, this is the step number 2. So step number 2, there is a table is clean. Again, it is a streaming table. Yeah, this is step number 2. Step number 3 is you materialize that one. So now this is the one which is a bit which is interesting. So you have two kind of materializing it. Either you need to keep history. Yeah, say for example, the point is like if the location of the customer was, his address was like in London previously, and now it is updated to Manchester. Now you have two choices. Either you forget about London, you just the latest one will be Manchester. So in the transaction data, they keep the latest ones. They don't care about history. They are not interested about history because they don't need that history. What they need is what is the location now, because they want to send the item to that person or whatever that is. So the active location, that's what they need. But also, if you want to do reporting, if you want to do for example, historical reporting, yeah, and then insight. If you want to know insight about that data, so you need to collect history. For that one, you need to do like another. You need to keep. You don't delete it or you don't discard that one. You need to keep the old one. So you will have all the old and the new in one place. That's it. So this is the second option. So now this is the materialized one, and this is the keeping the this is two section. One is keeping the old, and one is without keeping the old. Just as, yeah, this change. So some tables require just you need the new one, and some tables will require all the history one as well. Yeah, 2 records per record. So for example, if a customer or employee have changed 10 times, that employee will be registered 10 times. Yeah, that's not a duplicate. That is like you are keeping history. So that is what we are going to do now. This is, we have captured this change now. We want to materialize it. We want to put it in a table. We want to put like one line. Yeah, one line or 2 or 3 lines. We don't want now this update, delete for a customer. So for example, if a customer have like an update and delete or insert, he will have plenty, probably 100 entry. Now in your system, you don't want 100 entry. You want to, this is the same person. It has, his record has been updated, deleted, and so on. Yeah. So you don't want that 100 entry. Just you need one. But if you want to keep the history, the old one, then you need to put like the second one we see. But the record is like 1 per customer or per employee or per person. And you know that if you need like more records, yeah, you do it. You don't just put update and insert. Just that is the record of the person and you keep their history. Yeah. Now, to do that kind of exercise, you need to follow a specific like lines here. Again, don't forget we are doing the declarative one. Yeah, in the old way. This is like you are going to tell the Databricks that that's what you want, and Databricks will do behind the scene what we used to do in the past. Yeah. So in the past, if you want to do that kind of exercise, you do like a merge statement, and you write very long, depending on the data. Your merge statement might be wrong. For example, if you have a table with I don't know 200 column, you need to write. You need to monitor each all of them, all these columns. Yeah. And you need to write this merge statement for you need to update if they match, if they don't match, if you do this, yeah, for deletion, for insert, for update, yeah. So you compare the ID and then you insert it, yeah. So this is one by one. That's not declarative, yeah. This is not the one we are looking here is the declarative one, yeah. This is the way of Databricks implementation, yeah, of this slowly changing dimension as well, yeah. So that's what they're looking here. So we are going to create, of course, this is a destination, this is a customer, yeah. This is one customer which is without, this is the live customer, as it were, active one. So yeah, this is only the active one, and this is with history, the customer's history, yeah. Now, if you want to do this one, so again, it is a streaming table because you are going to streaming data. It is going to accept this customer table is going to accept streaming data, and you need to create a pipeline now. You need to create a flow. It's called a flow, and you need to name the flow. This is you need to create a flow here, and then you need to move the data through this flow. So you move it using this one, yeah. So auto CDC into your table here, yeah. You create a flow and then you move. This is the engine which moves the data to the destination, yeah. So this is again a declarative one you are doing, and now it is you are going the flow. This engine is going to move the data from the stream, which is we created the clean data. Remember, this is the clean data. And we are saying that we need to use the keys to identify whether a record is for a specific person or employee, yeah, or product, yeah. So this is the idea of the product or the employee. So an employee might have like 100, but that 100 is one. It represents one, but most of it is ID, insert, delete, and so on. So you need to give the key is mandatory. This key. So once you get this key, I mean, again, in the old days, you do like when you write a SQL, yeah, the join is they say this key is equal to that key, yeah. You do it yourself. Now you are saying to Databricks, yeah, use this ID as a key. Now this is now this extra bit, yeah, you see here is to format what is going to be here. Say for example, when you receive in the operation delete, yeah, delete the record. You don't want to delete this one, yeah. They say you can delete that record, yeah. Now it is very important also, yeah, to add this operation data. As I said before, on the table, on the change CDC table, what you will have is like each insert will have an operation date, yeah. So sometimes to for example, let us say a person's address changed, like the city where he was living he changed it in the morning, which is 9 o'clock, and then in the evening there is also another change, yeah. Now, but what happens was like the morning one didn't come, so there was a delay. It came later on, and then what will happen is if you don't have an order, if you don't have like when it came, if you don't order it that way, then your data will be wrong because you are going to update when the data comes in. For example, the 9 o'clock, it came like 6 o'clock, for example, and because it came 6 o'clock, it was the latest one. You can update it, even though the idea was like the 9 o'clock had been changed by, for example, 2 o'clock. Yeah. So because of that, you need to have this sequence, and the sequence will numbering. Yeah. Which one came first? For example, the 9 o'clock is first, the 2 o'clock second, 5 o'clock third, and so on. Yeah. So the operate, and then the sequence you would have like probably if there is a column with that sequence, good. If that there is no column, then you can use as says here, operation date, for example. Yeah. Now the other side is like again on for example Microsoft SQL, the CDC file will have operations, which is delete, insert, and so on. There'll also be operation date. There will also be like underscore rescue date and so on. Yeah. So these are metadata there. Yeah. To inform you what is happening. It's not your data that. It is not your data. So you don't want those ones in your data in the customer. So what you do is like the columns. You need all the columns except these ones, for example. Yeah. You don't want these ones. And now you indicate to Databricks that stored as SCD type 1. So this is one liner, which means Databricks now knows that you don't want history, and therefore it's not going to add to this customer the old data. Yeah. So this is for type 1. And then for the type 2, it is the same process. You create a streaming table. Yeah. And then you create a flow. This is the key part. The flow is this, create a flow, this as, and then the engine. This is the auto CDC into is the engine, which is going to move the data into the streaming table you created already. Yeah. It is going to move it, and it will move this data from the stream, the clean up you have done already, the data quality you have done in the second step. Yeah. So it's going to use that one, and it's again it's going to use a key. Databricks is going to use the keys ID key, and then if there is delete on the operation, then apply as delete. If there is a sequence by, now here is very important here. Now, even though you are saying delete here, if you identify it is like if you want the history, you don't want to remove it from the row. So what will happen is like it will flag it, it will end it. Yeah, it will end it. And therefore, because it is ended, there is no extra addition there on the file. There is no new one. Start and end, like, and then there is no record. So if, say, for example, if it's an update, the old one will have the start and end. It ended this time, and then the new one will have the start, but there is no end to it. Yeah. Again, here when you create this the SCD customer, yeah, when you create this table, you can do it like manually. You can create the columns, but if you do it yourself, you need to add two very important columns. One is called underscore start and then date, and then the second one is underscore end date. Yeah. But if you don't do it that one, so when you put it here stored as a SCD type 2, then what we'll do is like the Databricks will add the two column. They will take it from this operation date. Can you see this operation date? So the operation date will be when it happened, the insert or the update, yeah, whatever it is, when it happened, and therefore from it will populate the start and end date from this one. Yeah, so you don't need to provide it here, but again, if you want to do it like explicitly, there is no problem. But you need to add those two columns. Yeah. Now, again, it's the same thing. You don't want this metadata. Yeah, this all this metadata is not included, and and the sequence, as you said before, you need to operation date, yeah. So this makes like your file SCD type 2. Yeah. So this is the declarative one. So you are just saying, I want this one, but the how bit is done by Databricks for you. But again, even to understand this implementation, this is Databricks implementation, of course. Yeah. This is like this streaming table, this auto CDC into this create flow. Yeah, it is um I'm sure you don't see it there. If you say, for example, if you are going to do it in a Snowflake, you will do it in a different way. Yeah. Or if you want to do it, like for example, in Databricks in Fabric, you will do it in a different way. This is like purely in Databricks. So because it's declarative and it makes life easier. The code is like clean. It's just a couple of lines. Yeah. Just to understand them might take a bit of time, but once you understand them, they're very clean, and then you don't need to do it again and again. So that's what it is. So this is a pipeline for CDC. So if you have like streaming data, yeah, Kafka is the same thing. You can take the topics, yeah, from Kafka or from Event Hub, yeah. So you can take the topics there, and you can use the same thing, the same. Instead of the file CSV file, just you use them the topics now, yeah. So that is again a very important addition in the new Lakeflow. It's very addition and it's very important one. And we can see the same thing if again if you want to see the Python variant of this one. The Python variant is much like easier looks, yeah, than the SQL one, yeah. So this is the Python side here, for example, yeah. Again, because the reason would be like because you spend time on the Python code, the decorator, and so on and so forth. So once you spend the time understanding what decorators are and so on, just you decorate your file here, yeah. Now this is again the PySpark. I need to say here the PySpark is the new one. Again, Databricks has changed the way DLT operates. Now you can use open source PySpark, yeah, for the data, yeah. You can use that one. It's not proprietary. So the old one, I mean I think until last year, the DLT was the proprietary. Yeah, it was not open source, and you need to bring this DLT one here. But now you need to bring the Spark, PySpark, as you say, this is open source. And from there, you bring the pipeline and you work on it. And you call it DP. Yeah, not DLT. Just if you see here, it's not DLT. It's yeah, DP. And this is very interesting. You know, you see, you need to make it like these variables. The way you do the variables, you don't hard code them here, so that you reuse them again and again. Yeah, you can use different. You change it here, your catalog, and this one will be changed as well. Now the create pipeline here, as you can see, you have the create pipeline, and then you need to name it. Yeah. Now you have this decoration, the at dp.table, right? Making the table, and this is the row CDC. Yeah. So the row CDC, it is streaming, read stream, and the format you see, this is the in SQL, as you saw, read files. Yeah. And here is cloud files. Yeah, it's called cloud files. This is the autoloader. This checking whether something new is coming. Yeah. So the format is JSON here, and the infer column type is true. You need to put it through here. Is an option within the cloud file, as you see here. And this is load. This is the place where you take the data from. So can you see here? This is again your catalog, your schema. Now Again, you have a decorated temporary view here. And this is like the data quality here. The data quality. You see in SQL, we so expect this constraint in here. You just decorate it. You say expect or drop. You say, yeah, that is what you do here. The data quality valid data, expect or drop, valid ID. If the ID is not null, yeah, no rescue data, no valid operations in this one. So this is like a decoration which is slightly different from what the SQL was doing. Yeah, and it is it's decorating this file, the clean file. We call it in a table. We were calling streaming table there, but this is the table you are creating here. You see the again, it is not required, but it is always a good idea to on the decorator here, table name. This one should be the same as the function here. Function name and this one. This is the same thing. So this is the working, the workaholic one. Now you create a streaming table. You need to give it a name. This is the create auto CDC flow. Yeah. This is the target. This is slightly different here. Yeah. What is the target? What is the source? It is in here. It is more clearer. Yeah. It says this is the target and this is the source, and this is the key. The sequence by is this one, and ignore null update is false. Apply as delete. This is well, you need to write like expression here is a function, and accept columns list. They give a list in an array. So if you know Python, it's a clear and it's just straightforward. You decorate and put the one which is needed. Yeah. Now, it's the same again as I say, like that you need to have stored as CSCD one here. Put this is the one which changes to SCD in Python. Yeah, so this line make a lot of change, slowly changing dimension. Yeah, so that's again in the Python way of writing. So if you are happy to do it in Python, because I explained what was going on behind the scene, I'm not just going to do it again here. Yeah, it is the same thing. As you can see here, you need to use the keys, the source, the target. The name is different, but the way it has been implemented is the same. The concept is the same. Yeah, you need to have the source, the target, the engine, the pipeline, the flow. You know, you need to create a flow. In here, the flow is a function. Yeah, in the SQL, you just you create that flow instead of function. So here is like the difference is like the semantics, how you write them, but the concept is similar. Yeah, I hope you have enjoyed this session. It's a bit demanding, but it is very interesting topic because it covers like the CI/CD, sorry, the CDS, the CDC, the change capture. Yeah, that's what it was doing, and I hope everything is clearer. Thank you for listening, and if you enjoy or you feel that you gain something out of this, please subscribe the channel. And thank you very much. See you next.